Work. Somebody's gone this afternoon. I told them I'd record this for. Question on the homework? Yeah. What was your question?
Number 53.
53. 53. All right, graph each value of n. Describe how the multiplicity affects the graph. Well, I don't think I have to do that. If I put in 1, what's going to happen at 0.5? Let me see. Let me take this picture on 53. Yeah, just put it in the calculator. If I put in 53, if I make this to the first power, what makes the second factor equal to 0? Anything? Anything that's real? No. So there's no x-axis intercept. Okay, therefore, no solution. If you look for Descartes' rule of signs and x squared plus 1, you can see there's no sign changes either way. So no positive, no negative, and they're both non-real, complex numbers. So on this one, if you have it to the first, what's going to happen at, if this is 1, what's going to happen at 0.5? Will it cross or will it be tangent? It'll cross. Huh? Yeah, it's a 1. If I have x minus 0.5 squared, what's going to happen at 0.5? All right, it's going to be tangent. Now, whether it is going up or going down is irrelevant. It just wants to know how the multiplicity affects the graph. On this one, the graph's going to be tangent at 0.5. What about if you put a 3 in there? Right, if you have x minus 0.5 cubed, as Ms. Suits and I have talked about, there's a little extra right here where it looks like a little snake going through there. It looks like a cubic. And then what's the difference between a squared, if that's 1, and to the 4th power? Close. If it's to the 4th power, it'll just be a little narrower. It'll still be tangent because it's getting up closer or higher y values quicker.
So that was a thinking problem.
Yeah, it was a thinking problem and trying to figure out exactly how to answer the question. And also reading the words. There's a lot of words in that to try to figure out what's being asked. Okay? All right. William?
I didn't understand the 47 and 49 problem.
47 and 49. Is there a polynomial? There we go. Just a little bit more. There you go, 47. Is there a polynomial of given degree whose graph contains the indicated points? Well, first of all, I have a y-intercept, and what do we usually use that for? That usually tells us what? Usually tells us what a is. Okay? And then here's one x-intercept. Here is another x-intercept. Here is another x-intercept. Here is another x-intercept. What do we do with all those x-intercepts?
Where the either goes tangent or touches.
Yeah, it's where it's tangent or touching. It says it's to the 4th degree, so all these are going to be to what degree when you write them? There's 4 of them, so they're all going to be to the 1st degree.
They're all going to.
Yeah. So I have a times x plus 2, x minus 1, x minus 3, x minus 2.
What do you do with them? Is the 1, -1, -2?
That's the kicker. We find our equation. This tells us what a is. We put in 0 for all the x's and set it equal to -24. -24 equals a times 2, -1, -3, and -2. So we have 4 times 3 is 12, right? That's going to be a -12. So a has to equal what?
that's equal to.
Right, so that's equal to what? Well, if I put 0 in for x, y has to equal negative 24. If I put 0 in for all these x's, I have to set it equal to negative 24. That's the coordinate on the graph. We use this one to find a. The last one what? This point? That's what answers the question. See, up until this point, we've found an equation. What's different about finding the equation in this question? Is there a polynomial that contains the indicated points? We can always find this. Now, what do we do this last point? We check it.
Plug it in and see if it's true.
Yeah, negative 52. Does negative 52 equal 2 times, yeah, negative 1 plus 2. Now I'm putting in negative 52 for y and negative 1 in for x. I put in a equals 2. All I have to do is see if it's a true statement. If it's a true statement, it holds all those points. So negative 1 minus 1, negative 1 minus 3, negative 1 minus 2. So it's just like the ones we did yesterday, except there's one additional step. Usually stopped at A. Now we're checking the last point. So negative 52, does it equal, and some people put a question mark right here. Let's see, 2 times negative 1, positive 1, sorry. Negative 2, negative 4, and negative 3. Does it? 2, negative 4, 48, right? Negative 48 does not equal negative 52. So there's not a polynomial degree 4 that contains all those points. Okay?
That was fun.
Up where? All right? So that was fun.
Good question.
That's an extension of what we did yesterday. Yesterday we got to A, and today we just added one more step. Well, it's like, what do you do now with the extra point? You check it and see if it works. Okay? Fantastic. I think we're moving on, aren't we? Any other questions on the homework? I find it odd that one of them hasn't been brought up yet. Never mind, go ahead. Which one? 51? Oh, look at this question. That's a good one. It is 51. Using a scientist has limited data on temperature during a 24-hour period. If T denotes time in hours, isn't this exciting, Megan? It is excellent. This could be what you do in college. This is a data set. All right. Find the fourth degree polynomial that fits the information below. F of x. Exactly. Which one's x and which one's y? This is x. And so 0, 0, what is that?
Origin.
That is the origin. Would that be an x-intercept? Or would that be a point to use to find A?
No, it's an
Hey, what is an x-intercept? There seems to be some confusion. The generic form of an x-intercept is an x value, and then what does y equal? 0. So in this case, that used as an x-intercept or to find A. That is an x-intercept. X minus 0. This point, 5, 0, is a, okay, x minus 5. This point, 12, 10. Ooh, find A. 12 equals A times 10 times 10 minus 5, which is 5. 19 and 0. X-intercept, x minus 19. Don't forget, I'm putting in 10, or I'm sorry, 12. Wait a minute. I got that backwards. I'm putting in 10, and I'm putting 12 in for x. A times 12. There we go. 7. 12 minus 5 is 7. -7. All right, and the last one is 24. X minus 24. 12 minus 24 is -12. All right, so this one's used to find A, and the other ones are the x-intercepts. What is it? 10 equals what? 144 times 49. You have a big dog calculator right there. Punch it out. 7056A. That's just going to be a fraction.
Leave it.
Yeah, leave it as a fraction.
Yeah, say 10 over.
Right, you can divide them both by 2.
Equals 5 over 3.
And there's your equation. I know. F of x equals 5 over 35, 28 times x minus 5. Some people multiply this out, some don't. There we go. Fantastic. That is a very good problem. I like that. Rather enjoyed it. Any other questions on, will you finish write that down? What time do we got here? Oh, there you are. How you doing? Good. 10 for 10? I don't know. Sometimes things just happen. I have no idea how they happen. They just happen.
Spontaneous.
Exactly. Me? Sometimes. Some would say yes. Some would say no. Huh? It does depend on the day.
Smart work manage.
No, it just run a little slow. I need to know one thing. How did you do on 55? Let's do 50.
That's why we didn't have a question.
That's why. Let's do number 56.
4 or 6.
Graph and estimate all the real zeros. Determine the multiplicity of each. The reason I say this is the final will have a question very similar to this. You have to take a very difficult equation and use the calculator to solve it. That's one of the skills that you must demonstrate to get credit for this class. Parkland credit and also St. Joe credit. Okay, well, I gotta get my calculator.
I don't think you told the seminar class about that money thing because they were freaking out when they got the thing.
No, I didn't.
My mom was like, I might be $130 for it. Because I forgot to tell her.
I told my mom.
All right. Yeah, a lot of people were. But it's all taken care of. And usually people are pretty happy.
Okay, so I got a question. We're able to use these on our final, right?
Correct.
Okay, it's not gonna be like test.
Correct.
Can I use things in a Did you ever complain to that?
Nope, not yet. All right. Possibly a textbook fee to the high school. That's only to ensure the program can continue if they change textbooks. $10 is a credit hour, I think. That's what we're talking about. Times x caret 4. Oh my, yes. You're not doing that?
I am right now.
Good. Minus 19 divided by 8 times x caret 3. Minus 9 divided by 32 times x squared plus 405 divided by 256 times x plus, holy cow, 675 divided by 1024. Now, listen very carefully. It's understood that if the problem starts with exact values, it ends with exact values. All of our answers will be fractions. I'm going to go to the standard viewing window. I don't think that's going to work. Actually, I think I'll just go from -2 to -2 or something like that. -2 to 2. There we go. I'm not worried about the y's. I got them at -2 and 2. I don't want to see how high or how far down the graph goes. I'm worried about one thing, the x-intercepts. How many could there be? 5 of them at most. Okay? So, -2 to 2 looks like a pretty good window. Let's see how many we got.
Taking forever.
There's one. I went -2 to 2. On the Y's also. All right. It doesn't look that difficult to me now, actually. What do you think? Let's see if I can do this a couple times. Yeah, I'll do it like this. If you had this window in front of you, what multiplicity is this factor right here? What does this graph look like when it goes up, crosses, and goes over? Yeah, it looks like a cubic, so this has a multiplicity of 3. That's good because that gets us to 5 pretty quick. What's this multiplicity? 2. There you go. 2 and 3 make 5. Now I just have to find those answers. What strategy on the calculator can I use to find this one? What button can I use under second calculate? I can use second calculate 0. On this one, where it's multiplicity of 2, what can I use to find that one? You can guess and check with value. What else could you use? What's that look like to you? All right, with the vertex down there, or using the minimum feature on your calculator. That's under second calculate minimum.
That's on 3.
No, I'm saying this has multiplicity of 3. And this has multiplicity of 2. So if I can find those numbers, I'm pretty close. So this is going to be an x plus factor, and this is going to be an x minus factor. So that's going to be a negative number. And here's how you do it. Ready? Second, calculate 0. Based on how the factors look and how the graphs relate to those factors, tells you the multiplicity. Because it doesn't cross through the axis as a straight line. Straight lines have x to the first. When it crosses through like this, that looks like a cubic function. So this is going to be a third multiplicity factor. This is a parabola. Parabolas have x squared. It could have been x to the fourth, but 4 plus 3 is bigger than 5. So I know it has to be a 2. That's tangent. Okay. Well, on my calculator, I bet it does. Let's see, left bound, -2. Right bound, 0. Yes, -1. Sure, -2. No, left bound -2, right bound 0, guess -1. Now, what fraction is that going to be? -3/4, right? 0, -3/4. Yeah, this is on the left, and this is on the right.
Right.
Yeah, just a number, any number on the right side of that. Any number in between those two. Okay. So on the other one, I'm going to do minimum. Second, calculate minimum. Left bound, I'm going to go 0. Right bound, I'm going to go 2. And the guess, I'm going to go with 1. Nice. We've already discussed that 3 times. I have. What does that mean? There's a number, 1.3e. No, it's a number written in scientific notation. Very small, so small it's insignificant, which will make it 0 on the calculator. So this is 1.25. X minus 1.25 squared. The other one was x plus 3/4 cubed. Nice! I like that. Obviously, it's a skill some people are going to practice on their calculator. But that's why it's going to be assigned for homework, so you can practice that skill. Obviously, the higher calculator value number model you have, the easier it's going to be. Okay?
Convenient.
It is very convenient. Exactly. You have those things, you might as well learn how to use them. Now, let's see, what else is there? Oh! 55? Is this 55? 56? Well, 55 you can do for homework. I don't want to cheat you of your,
Learning.
no, your quality time with your studies.
Oh, I don't do it.
Well, yeah, you will, because the student solutions are online. Just download them. Sure, I just did the video.
Yeah, you can do the video on that.
All you're going to do is graph it out and see where it crosses. Let's see. On 54, graph f for each value. And describe, hey, we can do 54. Oh, we already did that. Let's see if there's another one like that. I don't want to do an odd problem because that seems like a waste of time to me.
You did one yesterday.
Yeah, for homework.
No, you really actually did one in class. That's why we were all laughing.
Oh, use graph to factor it. There we go. Did I do 46? I was going to, but I didn't. There we go. 46.
I thought we did it.
I don't think so. I think I talked about it. All right, so 46. The polynomial has only real zeros. Use graph to factor it. So on 46, this is another practice.
Oh, so you use graph that as
It's the same thing. We're going to graph it out and give it a go. Those people that have shut down, turn your calculators back on. Let's give it a go. Yeah, it says 46. X caret 5 minus, plus, minus 2.5x caret 4 minus 12.75x caret 3. This is identical to the last one, but it's not an odd, it's an even. Plus 19.625x squared plus 27.625x plus 7.5. Oh, 2 decimal points won't help. X to the fifth minus 2.5x to the fourth minus 12.75x cubed plus 19.625x squared plus 27.62. There we go. I think I'm ready. Now my window. Everybody in the room knows, well, let's put it this way. Everybody in the room has been told at least once that this answer has to, if it has a real zero that you can factor, has to be the factors of 7.5 divided by the factors of 1. Okay? That's the rational root test. So my window, I'll just go from negative 10 to 10 and see what happens. That captures 7.5. On the other one, I have very small fractions, so that's why it went from negative 2 to 2. So I'm going to go to zoom 6, standard. Wow, then the calculators will become immortal.
Yeah, look at this. Oh my goodness.
Hey, I see, how many am I looking for here? 5? I see 1.
2, 3, or
How many do you see here?
4.
But the 1, I'm going to shorten this up now. Window, negative 5 to 5. This is my second look at it. I'm going to take the y's down to negative 2 to negative 3 to 3. Okay, I just want a better look at it, not negative 55. Because I want to be able to clearly see what I'm doing in my work.
negative 3 and 3.
Yeah, the negative 3 and 3. That's what I'm going by. There's 1. Booyah. So there's 1. What's that one going to be? Parabola. So that's going to be 2. There's 3, 4, 5. Well, how do you know none of these are x cubes like on the last one?
So snake.
Right, there's no snake, and also take us way past 5. This gives us 5 right here. This gives us 1, 2, 3, 4, 5. And this is how you guess and check on the calculator. Negative 1, 2, 3. Second, calculate value. I'm hoping it's negative 3. It is. That's how you guess and check. So I can write down this factor is x plus 3. Do you want to mess with that one, or do you want to go to the other positive one first?
That's what the one. Let's get the big one done.
This one?
Yeah.
All right. So what button are we going to use for this one?
0.
Minimum. Second, calculate minimum. Left bound. What number is on the left of this little vertex? Negative 2. What number is on the right of this? 0. And then negative 1. Graph. How do you know that? Mine's not done. Or mine just crashed.
Do you change the colors on your graph?
Second, calculate minimum. Left bound is -2, 0, -1. There, now it's working. -1/2, right? X plus 1/2 squared. All right, any guesses for this one? Second, calculate value 2.5. It works. X minus 2. This is a fun way of factoring a polynomial. A lot different than synthetic division. You can't put 5/2 because the number out in front of the x to the 5th is a 1. So all the numbers in front of x have to be a 1 also. And then the last one is going to be what? Second, calculate value 4. There you go. X minus 4. There. That polynomial is factored. We have a double root. We have this root right here and this root right here. Why? You wouldn't know how to run it anyway. That's what part of this course is, and part of the course that we teach at Parkland is 1, the math, 2, how to use the calculator. Okay? It's very intimidating, especially if you're an older student and never picked up a calculator in like 20 years. That thing's very intimidating. But we try to take time to explain how to use it.
I think mine's just
The color? I like the color. Oh! I think we'll do a brain break and a few more problems. Stand up if you want to participate. If not, you can sit there. I don't care. That's fine. Morgan, sit there. I'm tired of trying to get people to participate. They want to. They can sit there like bumps. All right. Let's see. Andrew, you can do this one. All right. You need a partner for this after you learn the moves. Ready? After you learn the moves. The moves are you take your hands, put them over your ears. Then you take your left elbow to your left knee for 1. 1. There you go. They don't have to touch. Let's not get overly dramatic here. 7th hour yesterday, a kid fell into the desk, almost broke his knee. Then the next one, so that's a 1. Then 2 is right elbow to right knee twice. 1, 2. Good. Got it? So we got the first one. We got the second one. The third one is, right elbow to left knee 3 times. Okay, you got it? See, it's like a dance move.
It's like timeout.
Yeah, you can do that. You can do that like at prom. And then the last one is 4 reps of left elbow to right knee. Go. Scan across the midline.
Yeah.
All right, now everybody knows the moves. Face a partner, and I don't know. Can you do like any?
I don't know.
Yeah, there you go. Try your right knee. All right, so face a partner. Just watch them do it, and you do it. And we'll do it. Trevor, Hannah. Oh, got a partner? There you go. Right there. Huh?
To alternate?
No, do it at the same time. Ready? Same time. Go. You're doing that move. You're watching him do it. And you're doing it. There you go. 1. Look at him.
Like for 5, right arm to left knee.
Did you do it? Did he do it?
5.
Oh, try it again. I didn't see you guys. Huh?
What's 5?
There is no 5. There's 1, 2, 3, 4. Well, there is later on, but this is the first sequence of it. Okay. Did you get it?
Yeah.
Good. Fantastic. Did you get it? Did you get any of it?
I can do my left.
Okay, good. All right, have a seat. Again, it's just moves across the midline. No big deal. Back to working these problems. Back to sleep? Good. We'll do, the last one we're going to do is number 58. Then I'll let you get started on your homework. Okay? 58. It says the average increase in global temperature due to the greenhouse effect can be approximated by the following functions. Yeah. Now, these are just coefficients. You have t cubed, t squared, and t. Where 0, less than or equal to t, less than or equal to 60. That's your domain. When you set up a window, that's usually the domain you set it up with. And 0 corresponds to 1980. 0 is 1980. Use the graph of t to estimate the year when the average temperature will have risen by 1 degree centigrade. Wait a minute. We're looking for a jump of 1 degree. That's it? So we'll make the y scales go by 1. And we'll see how, we'll just give it a shot. Yeah, let's graph it out. Y equals clear. 21 divided by 5. 1, 2, 3. 1, 2, 3. I would separate it by multiplication. 1, 2, 3, 1, 2, 3 times x caret 3 minus 127 divided by 1, 1, 2, 3, 4, 5, 6 times x caret 2 plus 1, 2, 9, 3 divided by 5, 1, 1, 2, 3 times x. All right, now let's see, window 0 to 60. Probably go by, you don't want to go by ones. I mean, you don't want 60 tick marks. You go by fives. So that'd be like 1980 to 2040. Finally, estimating the yearly average has risen by. No. No. I think we are going from 2, and this is going to be like 0. We want to see when it goes up where y equals 1, don't we? All right, so let's take a look at that. We want to know exactly when it crosses, the first time it crosses 1 degree.
What was your x's again?
I went 0 to 360. Now, the only thing I don't know is, if this is the average temperature, what's the first average temperature? If I put it in 0, it's going to come out 0, isn't it? So once it goes up to 1, I got my answer, don't I? Does that make sense?
So you put 0 in for y min.
No. Yeah, I put 0 in for y min. I put 2 in. So I should see the first time it goes up to 1.
Hey.
Y equals, there's our equation. I put in 1. That's what I'm looking for. Right there.
I am.
This is, yeah, I'll use intersect for this one.
What's on there?
What's what? What? 0 to 60 for the domain. I went up by 5s. And now I can't use 0. I can't use minimum, but what can I use to find the answer? Intersect. So back in my graph, I can use second, calculate, intersect. Enter, enter, enter. So that's 37.12. Now, that's not the answer. That's not the answer. I got 37.127.
Subtract or add 37?
Huh?
You had 37 years in that. No.
Yeah, you had 37 years to 1980, I think.
But isn't it also? Why is it 37? Because I thought you said they were in things at 5 or whatever.
The scale, these are in intervals of 5.
Right. So then what you multiply?
No. This tells me the actual x value, which is between the, the 2 tick marks. Okay? So, I had 37 to 1980, and what do I get? Good. William? Yeah?
2000.
Yeah.
That's 2007.
2017. So based on this data, in 7 more years, the average temperature has gone up by 1 degree Celsius. Not centigrade, Celsius.
That's awesome.
Okay?
I didn't know you could do that.
Yes, Megan? It doesn't what? Oh! Oh, I still got time, don't I? Okay. That, see where it says Y1 up in the upper top? You press enter. Yep. Enter. And then that's close to where you're at, so press enter. There you go. All right. All right. So 2017, that's that. So today, we've talked about 3 ways of using a calculator to solve higher end polynomials. We talked about how to graph them out and use intersect, minimum on double roots or tangents, or maximum, and intersect if you have 2 equations you're trying to solve. Okay? So it's a fun Friday for calculators. For homework, you're responsible for knowing how to do all the way up through, let me take a look. I think it's 50, no, I think it's 59. It's 59.
There's like a chart.
Oh, not 59, so it will be 57. We haven't talked about regressions yet. Okay? So some of you only have a few problems. Some of you have a lot to do because you didn't really do a lot for today. So use that time. I'm going to stop this. And if you have any more questions, we still have a few minutes, okay?